User input. How to assign variables with user input. So far, we've covered how to assign variables values directly in a Python file. However, we often want a user of a program to enter new information into the program. How can we do this? As it turns out, another way to assign a value to a variable is through user input. While we output a variable's value using print, we assign information to a variable using input. The input function requires a prompt message which it will print out for the user before they enter the new information. For example, little snakes will assign to it, and then we have the input function, and we've put a string inside it. So we've put "do you like snakes?" ? Space. In the example above, the following would occur. 1. The program would print "do you like snakes?" for the user. The user would enter an answer. Yes, I have seen 7 pythons. I have 7 pythons as pets. And then they'd press enter. And that would achieve the following. The variable, which is likes snakes, would be assigned the value of the user's answers, so whatever they typed in. Try constructing a statement to collect user input on your own. So, try constructing a statement to collect user input on your own. Fill in the blanks in the code to complete a statement that asks the user, "What is your favourite flightless bird?" and then store their answer in the variable favourite flightless bird. So we'll say favourite flightless bird, and we'll assign to it input, and then in brackets, what is your favourite flightless bird? You got it. Not only can input be used for collecting all sorts of different information from a user, but once you have that information stored as a variable, you can use it to simulate interaction. So let's take a look at this code. So we have a variable called favourite fruit, and we've assigned to it, we've assigned to it this function. Input, what is your favourite fruit? What is your favourite fruit? Mango. Print. Oh cool, I like plus favourite fruit plus 2. So in other words, it will say, oh, so we've got concatenation here. So here's one string in speech marks. Here's another string in speech marks. And we have a variable. So we add them all together. So string plus variable plus string. So as if we'd get the string, oh cool, I like variable 2, but I think my favourite fruit is apple. And so this is what gets kind of printed. Oh cool, I like mango 2, because the value of the variable is mango. I like mango 2, but I think my favourite fruit is apple. These are pretty basic implementations of input. But as you get more familiar with Python, you'll find more and more interesting scenarios where you will want to interact with your users. Next. Article complete. You earn 10 XP each towards your skills. So you've got 2 skills on the go, your computer science skill and your Python skill. Introduction to control flow. Imagine waking up in the morning. You wake up and think, is it a weekday? If so, you have to get up and get dressed and get ready for work or school. If not, you can sleep in a bit longer and catch up a couple extra Z's. But alas, it is a weekday. So you are up and dressed and you go to look outside. What's the weather like? Do I need an umbrella? These questions and decisions control the flow of your morning. Each step and result is a product of the conditions of the day and your surroundings. Your computer, just like you, goes through a similar flow every time it executes code. A program will run, wake up, and start moving through its checklists. Is this condition met? Is that condition met? Okay, let's execute this code and return that value. This is the control flow of your program. In Python, your script will execute from the top down until there is nothing left to run. It is your job to include gateways, known as conditional statements, to tell the computer when it should execute certain blocks of code. If these conditions are met, then run this function. Over the course of this lesson, you will learn how to build conditional statements using Boolean expressions and manage the control flow in your code. Instructions. Click Next to proceed to the next exercise. Okay. Do I have to do anything here? Well, let's just have a look at the diagram. So morning, that's just in a rectangle, and then it looks like we've got questions in the diamond. So we go morning, is it a weekday? Yes or no. So if we say yes, well then get up at 6:30. Is it raining? Yes, wear a raincoat. No, don't wear a raincoat. So it's like the state or the action we've resolved to take is in a rectangle. Get up at 8:30, and then that just kind of leads to a question. Do I need to go outside? Remember, it's the weekend. Is it a weekday? No, get up at 8:30. Do I need to go outside? Yes, get dressed. No, stay in your PJs. Let's have a look at the cheat sheet for this. Control flow. So syntax error. A syntax error is reported by the Python interpreter when some portion of the code is incorrect. This can include misspelled keywords, missing brackets, too many brackets or parentheses, incorrect operators, missing or too many quotation marks, or other conditions. So here it says file, and then they've put in speech marks and also in angle brackets, standard in, comma, line 1. Syntax error, can't assign to operator. We cannot assign this to, we can't assign this to that, right? We can do 7 plus 5 assigned to age, but we can't do 7 plus 5 equals 4 to age. The elif statement, ELIF, which is short for, or an abbreviated version of else if. The Python elif statement allows for continued checks to be performed after an initial if statement. An elif statement differs from the else statement because another expression is provided to be checked, just as with the initial if statement. So remember, or learn if you haven't got this in your knowledge already, else means the leftovers. With computers, we have to account for all logical possibilities, so what we do is we divide the world up into two parts, and we deal with some condition and say, well, everything else if everything else holds, we'll do this. So usually we say if X, then Y. else do z. What if not x? So we say else do z. An elif statement differs from the else statement though, because another expression is provided to be checked, just as with the initial if statement. If the expression is true, the indented code following the elif is executed. If the expression evaluates to false, the code can continue to an optional else statement. Multiple elif statements can be used following an initial if to perform a series of checks. Once an elif expression evaluates to true, no further elif statements are executed. Pet type will assign to that the string fish. And we'll say if, and now we can talk about the values. So we can say, well, if pet type equals dog, print you have a dog. And then we say, so what elif is doing really is it's kind of dividing up the else region. So imagine you're using a cutter to make cookies. So you have this kind of metal ring, don't you? And you press it down you've rolled out your pastry and you press down the ring to cut out the cookie dough. And then you place it on the baking tray and put it. Well, the else is the cookie dough that's left when you've cut out the cookie. Okay? And then the thing we're interested in is the cookie, obviously, the stuff inside the metal cylinder. So we say if pet type equals dog, so that's our cookie, but then we have to deal with everything else. So usually what we do is if, and then we have the leftover cookie dough for the else. But what this kind of weird word is, elif, because it's not really a word, is it? What we're doing there is it's slightly different. What we're doing is we're dividing the leftover cookie dough up even more. So rather than just having it at the level of two categories, quite coarse-grained, and just saying this and this, with elif we're saying, well, within the else we've got the situation where a pet type is cat. It's not just dog and then everything else. It's dog, elif cat, else if it could be cat, else if it could be a fish. And then we do say, okay, now take the rest away. And we do finally have an else statement, and we say print not sure. And so just to give, right, got that? So we have the one elif, another elif, and then an else. So it's like this situation, or it could be this situation, or it could be this situation, and then else. That's the logic of it. This line is just a comment. This is performed. So if the pet type, that's the variable name pet type, if it is equal to fish, we've put fish in speech marks, and then we put a colon, then print you have a fish. If the pet type has a value of cat, print you have a cat. If the pet type has a value of dog, print you have a dog. The OR operator. The Python OR operator combines two Boolean expressions and evaluates to true if at least one of the expressions returns true. If one of the expressions returns true. So they don't have to both be true. Otherwise, if both expressions are false, then the entire expression evaluates to false. So again, these are just comments. So if we say true or true, that will evaluate to true. True or false, that evaluates to true, because we've got one true. False or false, that evaluates to false, because there is no true. False or false just evaluates to false. 1 is smaller than 2. That evaluates to true. 1 is smaller than 2, which is true, or 3 is smaller than 1, which is obviously false. So it's basically true or false. Well, that evaluates to true. If we say this expression or this expression, that evaluates to false, because it's not true that It's false that 3 is smaller than 1 and false that 1 is bigger than 6. 1 equals 1 or 1 is smaller than 2. That evaluates to true. So we say we're combining two Boolean expressions. Okay, so combining, well, the whole thing is a combination, isn't it? This is a Boolean expression and that's a Boolean expression. And that's a Boolean expression and that's a Boolean expression. So that's the OR operator. But notice how we can do it with these inequality expressions. So that's not a Boolean as such, is it? The equal operator, which is equals equals. Right? Equal equal, of course, different from the assignment operator. The equal operator is used to compare two values. Compare is used to compare two values, variables, or expressions to determine if they are the same. If the values being compared are the same, the operator returns true. Otherwise, it returns false. The operator takes the data type into account when making the comparison, so a string value of 2 is not considered the same as a numeric value of 2. Okay, so again we have the string value of 2 and the numeric value of 2. Let's have a look at this code. So, equal operator. If yes, that's the equal operator. Yes, colon. You've seen we use a colon after an if, just like after the else. Then print, this is the print function. We know it's a function because it's in rounded brackets. They are equal. And notice how you don't have to use double speech marks. They don't here. So print they are equal. If 2 is greater than 1, so this is one expression, and here is a second expression. So if this expression is equal to this expression, print this. Now look at what we're printing. Both expressions give the same result. In other words, are they both true? Well, they are. 5 is smaller than 10, truly, and 2 is bigger than 1, truly, so it makes sense to print that, doesn't it? Both expressions do give the same result, true and true. We have two lines here where we just have assignment. So C assigned to that 2, that's a string, and D assigned to that, this numeric 2. So the data type here, it's a numeric value of 2. So D has assigned to it 2, the numeric value. And we say if C is equal to, remember, the equal operator is used to compare two values. Then print they are equal, right? If colon, else. Don't note, it's strange, isn't it? Else, we put the kind of condition we're interested in on the same line as the if, but there's nothing on the same line as the else. If C is equal to D, else print they are not equal. So if and else, we're dividing the world into two things. Cookie, leftover dough. We're not interested in this half of the leftover dough and the other half of the leftover dough. If we were, then we'd do if and then else if, elif and then elif. Or rather if and then elif and then else. But we just if and else. Else colon print they are not equal. Now the not equals operator. This reminds me of the AE operator, the add equals operator, which is plus and then equals. The Python not equals operator, exclamation mark equals, is used to compare two values or two variables or two expressions to determine if they are not the same. If they are not the same, the operator returns true. If they are the same, then it returns false. The operator takes the data type into account when making the comparison, so a value of 10 would not be equal to the string value 10, and the operator would return true. Okay, so the string value 10 would not be the same as the numeric value 10. If expressions are used, then they are evaluated to a value of true or false before the comparison is made by the operator. Okay, that answers a question we had before, yeah. So if we do 10 greater than 1, that gets collapsed down or evaluated before into a boolean, and then we can do the comparison. So it's called the not equals operator. So it's exclamation mark equals the not equals operator. So if yes, not equals no, then it evaluates to true. Print they are not equal. So if yes is not equal to no, well, it's not. Yes is not equal to no, so it's true. Here we have a variable with a numeric value of 10 being assigned to it. So we have val1 equals 10 and val2 equals 20. If val1 is not equal to val2, then print they are not equal. If 10 is greater than 1 is not equal to 10 is greater than 1,000, print they are not equal. So if this print, two print functions. Comparison operators. Well, we've mentioned, okay, so it's talking about greater than or equal than. But in a way, the not equals operator, that exclamation mark, then the equals. Yeah, so it's kind of big and then slash for the equals. That's a kind of comparison operator. That's kind of a comparison operator, the equal operator. But there are these proper sort of comparison operators. In Python, relational operators compare two values or two expressions. The most common ones are less than, greater than. Here we have less than or equal to, and then we have greater than or equal to. If the relation is sound, then the entire expression will evaluate to true. If not, the expression evaluates to false. And let's look at the examples. A is smaller than B. Well, is it? It only makes sense if we translate these letters into numbers. Well, if A is 2 and B is 3, is 2 smaller than 3? It is, so that evaluates to true. Is A bigger than B? No, so we say it evaluates to false. It collapses down, evaluates. A is, well, we've not seen this yet. Arrow to the right with an equal sign. That means A is bigger than or equal to. So the same as or equal to. Is A bigger than B? No. So that evaluates to false. A is 2, B is 3. So A is not bigger than 3. So A is not, so that's false. A is smaller than or equal to. Notice the words I'm saying, smaller than or equal to. I'm not saying equal to or smaller than. I'm saying smaller than or equal to. Those words come at the end, or equal to. And that explains why the order of the symbol. So it's arrow equals sign, arrow equals sign, arrow equals sign. That's the order. Tends to be that. Exclamation mark equals sign. Let's move on. So those are the comparison operators. Smaller than, greater than, smaller than or equal than, smaller than equal than, and then they've put that. Okay, you can also do A in relation to itself, which we might call a reflexive relation. Is A smaller than or equal to A? Well, it is, because it is equal to itself. The if statement. If expression colon, don't forget the colon, and then you put stuff underneath the line which is indented. Let's read. The Python if statement is used to determine the execution of code based on the evaluation of a Boolean expression. If the if statement's expression evaluates to true, then the indented code following the statements is executed. If the expression evaluates to false, then the indented code following the if statement is skipped, and the program executes the next line of code, which is indented at the same level as the if statement. Do you see? So if test value is greater than 1, well, what's test value? What's the value we've assigned to that variable? Well, it's 100. So that's true. So then we now we move to the indented stuff. Okay, fine, print that. If test value is greater than 1000, print this code is not executed, because that's false, isn't it? So we actually never get to that. We never get to those lines of code because this returns false. The colon here is like a sort of wall, a barrier, and we only punch through that barrier if this expression turns out to be true. Well, 100 or test value is not greater than 1000, so we don't ever punch through that colon. So we do print out this code is executed. Either way, we do get to this line of code, which is print program continues at this point. The else statement. The Python else statement provides alternate code to execute if the expression in an if statement evaluates to false. So it is linked to the if statement, alright? So we said before, if we don't punch through that colon, then we just move on. But you might say, well, I want us to kind of note the fact that we didn't punch through the colon. And that's what you can do with the else statement. You know, you can say, I don't want to just go, okay, that failed, move right down to here and carry on as if nothing happened. I want you to do something because of the failure. I want the code to go, okay, the if failed or evaluated to false, so I want them to be some logic that runs because of that false evaluation. And that's what you can achieve with this else. So if expression colon, else colon, and then the logic here, and it's just a print function. Let's read. The Python else statement provides alternate code to execute if the expression in an if statement evaluates to false. The intended code for the if statement is executed if the expression evaluates to true. The indented code for the if statement, that does get executed if the expression evaluates to true. The indented code immediately following the else is executed only if the expression evaluates to false. To mark the end of the else block, the code must be unindented to the same level as the starting if line. Let's read that again. To mark the end of the else block, the code must be unindented, so out normal, unindented, to the same level as the starting if line. So what we're saying is, let's say we've got an else block here, and we've filled it out with this, fleshed it out with this print function, yeah? Well, the question is, well, when are we finished? Are you done now? And the way you let the interpreter know is you just remove the indentation. So carry on without the indentation. So if we look at this line, test string equals valid, you can see that this line, test string equals valid, it's gone back to the right on the left-hand side of the block. And that's just, and to mark the end of the else block is nothing but doing that, removing the indentation. That's how we mark the end of the else block. The AND operator. The Python AND operator performs a Boolean comparison between two Boolean values, or two variables, or two expressions. If both sides of the operator evaluate to true, then the AND operator returns true. If either side, or both sides evaluates to false, then the AND operator returns false. We'll read that again. If both sides of the operator evaluate to true, then the AND operator returns true. So it's quite strict. Both have to be true. If either side is false, no, the whole thing is false. Do you see? A non-Boolean value will always evaluate to true when used with the AND operator. Wow. So it really does have to have things that are either actually Booleans or things that sort of collapse into Booleans, like this expression, 1 equals operator 1. So if you have true and true, well, that does evaluate to true because the AND operator is very demanding. It needs truth on both sides, but it's got it. So yeah, that evaluates to true. If we say true and false, not good enough. So that evaluates to false. As we said, the AND operator is very demanding. And what about false and false? Well, that evaluates to false. 1 equals 1, and 1 is smaller than 2, well, that will evaluate to true. 1 is smaller than 2, and 3 is smaller than 1, well, that evaluates to false. Why? Because 3 is not smaller than 1, so that side is false, even though that side is true. Yes, and 100, well, that evaluates to true. Okay, moving on. Why does this evaluate to true? Why? Because we've got a string here, which is a non-Boolean value. That what is that an expression? Maybe that is an expression. Is it? I don't know. But the point is, a non-Boolean value will always evaluate to true when used with the AND operator. And this is a non-Boolean value. Question is that a non-Boolean value? You know, 3 is smaller than 1. That's either true or false, isn't it? I mean, there's a relation there. There's a mapping of one thing to another. So does it map or does it not map? But if you just have 100, it's not false, but it's not true either. It's not clearly true or false, is it? It's just there. So I'm not sure if maybe that's not a Boolean either. So that's a non-Boolean, so the whole thing evaluates to true, which is kind of strange, because you might think that the AND operator only evaluates to true if both sides of the operator evaluate to true. You might think that. But that's not quite true. Because here's a situation where both sides have not evaluated to true, and yet we have the whole thing evaluating to true. I mean, it's there for you to see. So it's not actually true that if you've got this AND operator that's coming across as true, that's evaluating to true, both sides are true. And you might think, well, didn't you say... No, we didn't actually say that. We said if both sides of the operator evaluate to true, then the operator returns true overall. Right? But we didn't say that if the operator returns true overall, then both sides are true. That's the flip of that. Okay. Boolean values. Booleans are a data type in Python, much like integers, floats, and strings. However, Booleans only have two values, true, false. Specifically, these two values are of the bool type, B-O-O-L. So sometimes we just say bool, all lowercase letters, not boolean, bool, B-O-O-L. Since booleans are a data type, creating a variable that holds a boolean value is the same as with other data types. So we can say is true, we'll assign to that a true value. Is false, we'll assign to that a false value. And here we have the print function. And finally, the not operator. The Python not operator is used in a Boolean expression in order to evaluate the expression to its inverse value. If the original expression was true, including the not operator would make the expression false, and vice versa. So if we have not true, well, that evaluates to false. If we say not false, that evaluates to true. 1 is bigger than 2, that evaluates to false. Not 1 is bigger than 2, that evaluates to true. 1 is equal to 1, that evaluates to true. Not 1 is equal to 1, well, that's false. So that's what a cheat sheet looks like, and we've got a button here where we can print the cheat sheet and even share the cheat sheet to your Facebook friends, so that your Facebook friends will know about Booleans. Here's another cheat sheet on lists. Where were we? So let's go next. Okay, control flow, Boolean expressions. To build control flow in our program, we need to be able to check whether a condition is true or not. For this, we use Boolean expressions. A Boolean expression is a statement that can either be true or false. The statement must be answered by true or false only, and it must be verifiable with evidence. It cannot rely on interpretation or opinion. To understand this, let's go back to the waking up example. The first question, is today a weekday, can be written as a Boolean expression shown below. Today is a weekday. This expression can be true or false if it's a weekend. There are no other options. We know the answer is verifiable and it does not rely on an opinion. You know, I'm very suspicious of that. Just because something relies on an opinion, it can still have a truth value, I think. Or at least, there are situations where we rely on experts to come to an agreement. Anyway, now consider the following phrase. Friday is the best day of the week. is this a Boolean expression? Well, it is a bearer of truth because it's a statement. We have the copula, the predicate, and the subject, the thing we're predicating the something of. But of course, this statement is an opinion and is subjective. Someone might say that Wednesday is the best day, and their statement would be no less true or false than the one above. Well, that's really what if there are 3 doctors and one says this is the best course of action and the other says this is not the best course of action? Well, we don't want to start saying that one of the doctor's statements is no less true or false than the others, because we care about the truth in that situation, and one of the statements probably is true. And we don't talk about, I was going to say degrees of truth, but they don't quite go far as to stress that. But the point is, in most situations, just because we can't establish the truth of the matter doesn't mean we're not dealing with truth bearers. I'd want to say that when doctors give an opinion about what the best course of action is in an emergency situation on a patient, the statements they give are still truth bearers, even though they're opinions. How about the following? It's just that it would take so long to sort of verify and investigate what they're saying that we wouldn't, and it would be impractical to find out who was true, who was saying the true statement. Anyway, the point is, Friday is the best day of the week. It's not a Boolean expression. No, this statement is an opinion and is subjective. How about the following phrase? Sunday starts with the letter C. Yes, this is a Boolean expression since the answer can only be true or false, and it is verifiable. Even though the statement itself is false, it is still a Boolean expression. Now we have some instructions. Examine the following statement. The Earth revolves around the Sun. If you think it's a Boolean statement, set the variable first statement to yes. Okay. Else, set it to no. Okay, run. Okay. Now, consider the following statement. The moon is made of cheese. If you think it's a Boolean statement, create a variable second statement and set it to yes. Otherwise, set it to no. Okay. And that gets ticked automatically. Next, consider the following statement. Chocolate ice cream tastes better than vanilla. If the statement qualifies as a Boolean expression, initialize a variable third statement to yes. If it doesn't, initialize the variable third statement to no. How do we initialize a variable? Well, sometimes we can do initializing of variables by just creating a blanked out speech marks or a blanked out brackets. Is that right? Anyway, we initialize them like that, but I'm just going to go straight in and just say, okay, have this string as a value and put no. Run. Okay. Video walkthrough. If you get stuck during this lesson or would like to see an experienced developer work through the lesson, watch this lesson walkthrough video. Let's have a look.
About expression is, and what does and doesn't qualify as a Boolean expression. So what is a Boolean expression? A Boolean expression is a statement which has an objectively yes or no answer. In Python, this is represented by a true or false value. Boolean expressions cannot be subjective statements, such as opinions. Let's take a look at some statements on the right to determine whether they are Boolean expressions or not. The statement, "Today is a weekday," is a Boolean expression, since, depending on the day, it will return either true or false. The next example is the statement, "Sunday starts with the letter C." This is also a Boolean expression, since, although it is always false, it has an objective yes or no answer. The last example is the statement, "Friday is the best day of the week." This is not a Boolean expression, since the answer varies depending on who's answering the question. There's no way to prove that Friday is the best day of the week. Being able to determine whether something is a Boolean expression...
It's not up to you to make statements like it can't be proven that Friday is the best day of the week. You don't know that we can prove that. And this might be a trivial example, Friday's not the best day of the week, but what about when it comes to other statements like this tax policy is the best for the country? Can that be proven? Or there's no cure for this disease. Can that be proven? So it's not for you to say that. That is a truth bearer. Friday is the best day of the week.
Or not, enables us to write effective control flow in our Python programs. This is because programming languages don't inherently know how to handle values that aren't concrete, like true or false. Now let's practice Boolean expressions by tackling the instructions portion of this exercise. This exercise asks us to determine if three statements are Boolean expressions or not. First, we have the statement, "The Earth revolves around the Sun." Remember, to qualify as a Boolean expression, the statement must be true or false and objective, meaning it is based on verifiable evidence rather than opinion. Since this statement is objectively true, we know it's a Boolean expression. So let's set first statement to yes. And hit run. The next statement is, "The moon is made of cheese." Let's think about this for a moment. We know that the moon is not made of cheese, but it is verifiable, and the answer can only be true or false. Since we know that this statement is objectively false, it is also a Boolean expression. So let's create a variable, second statement, and set it equal to yes. And we'll hit run again. The final statement is, "Chocolate ice cream tastes better than vanilla." In this case, this statement can be answered by true or false, but it depends on an opinion. The answer changes from person to person, and therefore is a subjective statement. Because of this, it is not a Boolean expression. Now we'll create a variable called third statement, and set it equal to no. That's it for this exercise. Before we move on, let's look at one of the frequently asked questions for this exercise. A commonly asked question by Codecademy users is, can Boolean expressions be combined into a longer expression? The answer to this is yes. Boolean expressions can be combined using Boolean operators, which we'll learn about later in the lesson. Some common Boolean operators are and, or, and not. Exercise number 3, Relational Operators, Part 1. In this exercise...
Okay, I'm going to click next. And this is the next exercise on relational operators. And relational operators, so we have the equals operator, not equals, not equals, equals, not equals, and we're going to do this one next time.